Hey guys, Mrs. Young here. Just wanting to give you a chance to go through the study guide one more time with me. So here we go. The first question asks us about distance and displacement. Remember that distance is the total path taken. So we would be measuring all of those. When we added up all those sides, that gave us 17. And displacement is the difference between the first and the final position of an object. So in this case, my answer is 3. Remembering that the only time that distance and displacement are equal is when they are heading in the same direction. So if this is 90 feet and this is 90 feet, like we're running to first base with our baseball analogy, our distance and displacement is going to be the same. The minute that we turn the corner, our distance and displacement no longer equal themselves. Reference point is the starting point you choose to describe the location or position of an object. In our book was the park scenario where our reference point was going to be the statue or the drinking fountain to try to locate our favorite picnic table. So the reference point has to be something that you can find easily and that is stationary, not something that is going to move like a bird or a piece of trash on the floor or a man sitting on a bench. All those things are going to not be there the next moment. So you have to pick something that's stationary, like Starbucks or Taco Bell. All right, so starting point you choose to describe the location or position of an object. So then also to describe the position, we need to have the distance and direction from that reference point. So you're going to go to the statue and you're going to head towards the slide. That gives you your direction. And you're going to go 100 meters. That's going to give you your distance. Or more so might be something like this, where you're going to go to Starbucks and you're going to go 3 blocks north to find your object. So motion is the process of changing position. If something is at rest, it is not in motion. As soon as it changes position, it is in motion. Displacement, we've already talked about, is the difference between the initial and the final position of an object. Remember that if our runner runs once around the track, the distance and the displacement is 0. Or if our batter hits a home run, the difference between where he started and where he ended, since it's the same, it is 0. So displacement will be 0 if you start and end at the exact same spot. Speed is a measure of the distance an object travels per unit of time. So here is our formula. Distance divided by time. How far did we go? And how long did it take us to do that distance? You're going to divide those numbers out. Constant speed is the rate of change of position in which the same distance is traveled each second. So let's change our color. So this would be constant speed. Okay, this moment we're going the same, still going 65, still going 65, still going 65, constant speed. The rate change here is actually going to be 0. The rate of change of position in which the same distance is traveled each second. So with that, then we're going to have 0 change in speed. All right, instantaneous speed would be speed at a specific instant in time. So you might look at your speedometer in the car or on your bike and see that it is 65 miles per hour or 22 miles per hour. That's your instantaneous speed at that specific instant in time. Average speed. Total distance traveled divided by the total time taken to travel that distance. So it's total distance divided by total time. So for example, we might be going on a trip and it might take us, we might be going 180 kilometers and it might take us 3 hours to travel that 180 kilometers. To find average speed, we would divide those out. 180 divided by 3 would be 60 kilometers per hour would be our average speed. Chances are we did not go 60 kilometers per hour the entire time. We would speed up, slow down, depending on traffic, depending on if we're taking a restroom break, all right? But looking at your total distance, which would be 180 kilometers, dividing by the total time it took us to do that, would give us our average speed. Velocity is speed and direction of a moving object. To have the same velocity, objects must be traveling at the same speed and in the same direction. So we've already talked about speed, knowing that that is distance divided by time. When we have our speed unit, it is a two-part unit. It will have a distance component, which is going to be meters in this case, and a time, seconds. So it's always going to have some type of distance, whether that be kilometers, whether that be meters, whether that be miles, whether that be yards. You're going to get that from your story problem. And also then your time would either be seconds or minutes or hours. Once again, you're going to get that from your story problem. So you need to have some type of speed and then direction. We might have the cardinal directions of northeast, southwest, but we also might have the directions like to the left, to right, up, toward the end zone, toward home plate, like some of the scenarios when we had with our acceleration card sort. So you're going to have two things that you need for velocity: speed and direction. Acceleration is a measure of the change in velocity during a period of time. Changes as a result of increasing speed, decreasing speed, or changing directions. We will go over acceleration a little bit later when we do our calculations. So now, this is going to be where we're going to be finishing up our first video, is just getting through these calculations. It's going to be super important that you guys are comfortable with the distance, speed, time triangle. You are going to cover up what you're trying to find. So a train traveled 350 kilometers in 2.5 hours. What is the average speed? All right, so I'm looking for speed, so I'm going to cover that up. What do I need to do? Distance divided by time. I'm going to go back into my story problem and figure out which one is my distance and which one is my time. I know that 350 kilometers, I know that that's my distance because meters is a distance unit. So that is going to be my numerator, 350 kilometers. Divide by my time, 2.5 hours. I know that's time because I have a time unit attached to it, hours. Divide by 2.5. Divide that out, gave me 140 kilometers per hour. I can't cross off any of those. I have to use both of them. But remember, I am finding speed. For me to find speed, the unit will always be a two-part answer. One showing the distance and one showing the time. So in this case, it is kilometers per hour. It might also be meters per second or miles per hour if you're using U.S. customary. All right. Now, what am I looking for next? I'm looking for time. So I need to cover up my T in my story problem. How much time will it take? All right, so I'm covering up my time. To take a bug to travel 5 meters across the floor if it is traveling at 1 meter per second. All right, so I'm going to divide distance divided by speed. What is my distance? So I have to locate that in my story problem. That's 5 meters. What is my speed? 1 meter per second. I know that speed because it has two parts to the unit, a distance and a time. And there is my speed. So I'm going to divide that out. Distance divided by speed. Distance divided by speed. And that gives me 5. 5 what? Well, I'm able to cross off my meters, leaving just seconds. 5 seconds. I'm going to stop and I'm going to double check. Does that make sense? I'm trying to find time and my unit is seconds. Makes sense. All right, now I'm going to look for distance. If an object falls at 9.8 meters per second, how deep is the backyard well? All right, so that's going to be a distance. I'm trying to find out how far. All right, when you drop a rock down, it will take 7 seconds. So I have to multiply speed times time. So what is my speed? 9.8. I know that's my speed because it has 2 parts in the unit. Multiply by my time, 7 seconds. I'm going to use a calculator for this. 9.8 times 7 gives me 68.9 meters. I'm able to cross off the units that are the same, leaving me just with meters. And I'm going to double check. Does that make sense for distance? 68.6 meters. It makes sense. So this is the end of the first video. We will pick up with acceleration with video number 2.